Hi again, guys. We're back to this e-learning. I did get a couple of questions on the most recent homework. I believe it's 1.5 on how to write in graphing form. We are going to talk about this in class tomorrow, but I just thought I would do a quick one on here with you guys so you could see one. So in order to get it in graphing form, you're going to need something squared plus or minus something out here. So in order to get this, we need a perfect square, which a perfect square, when you think about the definition of a square, it has to have both sides matching. So like 5 and 5, 6 and 6. In this case, when I go to draw my factoring rectangle, instead of it being a rectangle, I want it to be a perfect square. So if I put an x there and an x there to get x squared, I'm good. Both my sides match so far. They both have an x on them. Now, in order to get this 6x, it's going to be broken up between these two squares, just like it normally is. But normally we have the possibility of it being 4 and 2, or 5 and 1, or a bunch of different ways to get 6x. If I want it to be a perfect square, though, I'm going to need it to match on both sides. So I'm going to need 3x and 3x. The reason I did that is so that on each side it'll be x plus 3 and x plus 3. Now here's the problem. That makes this box in the lower corner 9 because of the 3 times 3 on the outside there. However, we wanted it to be 11. So that means we were too short. So what we do is when we go to write our equation in graphing form, we have x plus 3 squared, which gets you all that stuff that's in the box there. It gets you this x squared, it gets you the 6x here, and it gets you 9. So on the outside, what we're going to have to do is add 2 so that we get y equals x plus 3 squared plus 2, because that 9 plus 2 more on the outside gets you the 11 you're looking for. So hopefully that'll help you on the ones on the homework like that. Okay, get this erased. Normally it erases for me. Okay, we're also going to talk a little bit today about comparing these two graphs. So okay, so I got that stuff moved out of the way. I also moved myself over to this other corner so that you could see the graph. So in this graph, if we look at the equations up here, see if I can get this. If we look at the equations up here, what I'm hoping you notice is that the only difference between these two is that this one has this value that we put a there when we wrote it before. This one has 4. This one doesn't have anything there. So this top one is the red parabola on this side. So what I want you to notice is from that vertex that you get from that equation of 3, negative 4, when this one went over 1, it went up 1 as well. And then if you go over 1 again, now it's going up 3. And then over 1 again and up 5. Now what you're going to notice is this blue one looks skinnier because it's going up 4 times that amount each time. So it goes over 1 and up 4 instead of 1. Then on the next one, it's going to go over 1 and up 12 because it's going 4 times as much as the previous one. So that number out in front tells us how wide or skinny that parabola is going to be each time. So when we have something like 4 out front, you can see that it gets much skinnier. So we're going to open up this. So what I want you to keep in mind is I posted these slides as well with this video and the questions that you have to answer. This is linked. If you could at this point just open this link up It's going to take you to Desmos where you have a slider that you can play around with to see how it changes that parabola as you change that value out in front. And then you're going to compare that to the situation that's given on there. So I'm going to have you guys kind of do that on your own. But here's what this is going to mean when we start talking about setting up equations is just because I have the vertex doesn't mean that I'm going to be able to write the equation correctly right away. So what the vertex allows me to do is get most of my equation down in that graphing form. So if I have that vertex, okay, I know that in here is going to be x minus 1 squared from that 1 there is the vertex, and then out here is going to be minus 8. Here's the problem though. I don't know how wide or skinny that parabola had to be in order to get this y-intercept of negative 6. So what I don't know that means is this a value out front. That's the part that I'm not sure of yet. But what I can do is because I know that it also goes through this point, I have an x and a y value that I can plug in. So what we're going to do is we're going to take negative 6 and we're going to plug it in for y here. And then the rest of our equation will stay the same. Except then for the x, instead of leaving it as x, I'm going to plug in 0. Because that was what my x value was. Trying to keep it color coded so you can see what I'm talking about here. And then what that allows us to do is now the only variable that we have in this equation is that a that we don't know that we're trying to solve for. So what we can do is we can take the steps that we already know how to go ahead and solve this. So negative 6, I'm just going to start simplifying it a little bit, equals a. Well, 0 minus 1 is negative 1, but then squared is 1. So a times 1 minus 8. And then I'm going to add 8 to both sides to cancel that out because remember I'm trying to get a by itself here. And then on this side I'll have 2 equals 1a is the same thing as just a. So I get that a equals 2. Once I have all that information, now I know my full equation. So because I have that vertex and I know the stretch factor that gets it to hit that y-intercept at negative 6. So I get y equals 2 times x minus 1 squared minus 8. So we just took the information that we knew, which was the vertex, plugged that into our graphing form equation, took the other point, plugged that in for x and y, and then solved for a. So what you can do here on this one, so you can go ahead and try this one out. So you know the vertex, you know the y-intercept. Try this one out, pause the video and try this one out and see if you can get it on your own. So what I'm hoping is that you also got a value of 3. So your equation would look like this when you're totally done. Y equals 3 times x minus 3 squared minus 3. If you have any questions about that, try and go back to the last example that I did and see if you can make sense of that for this one. Or I'll be available from 8:30 to 12:30, so email me, text me, or I can start a Google Hangout with you as well. All right, that's all for you today. Have a great last day off. I hope I'll see you tomorrow.